Guys, Mr. Wilson here. We're looking at the notes that we didn't finish in class yesterday. So I'm not going to be in class today. So sorry about that. We're going to kind of finish the notes here, and then I have a few things for you to do afterwards. So let's just go through examples too. I know some classes we started it, but I'm just going to run through the whole thing again just to review. So we're going to start by finding our vertex. And what we have to do, if we look at our notes from yesterday, we said this is what standard form looks like. And in order to find the vertex, we're going to evaluate x is equal to negative b over 2a. And where a is the number in front of x squared and b is the number in front of x. And this x is going to represent the x of the xy coordinate for the vertex. So we also have to solve for y afterwards. So let's start by and find the x portion first. So x is equal to negative b over 2a. It's always a good idea to start by writing that down. Our b value here is negative 4. So we have a negative of our b value, which is negative 4. And I'm putting that in parentheses because negative negative makes it positive. And 2 times our a value, which is negative 6. So negative negative 4 becomes positive 4. And 2 times negative 6 is negative 12. And I'm going to simplify that fraction. That's going to give us, well, what number goes into 4 and 12? 4. So we divide each of these by 4. That's how we simplify fractions. 4 divided by 4 is 1. 12 divided by 4 is 3. And now we still have a negative. So our x portion is negative 1/3. So that's going to be the x portion of our vertex. So our vertex is going to be the point negative 1/3 comma something. In order to find that something, we have to take our answer and substitute it back in for x in our original equation. So we're going to get y, right, because we think about this guy as y. Those are the same thing. So y is equal to negative 6 times our negative 1/3 squared minus 4 times negative 1/3 plus 7. This is pretty gross. There's a lot of fractions. We're squaring stuff. It's going to get messy very quickly. If you do this on your calculator, which I encourage you to do, just be very careful about your decimals and things like that. Just be aware of what they mean. So here, I'm going to do it out by hand so you can at least see how you would do it if you wanted to do it by hand. So first thing, we got to get rid of our exponent. So negative 1/3 squared means negative 1/3 times negative 1/3. You can even do that little portion on your calculator. That's going to give you 1/9. 1/3 times 1/3 is 1/9. Here we have a negative 4 times a negative 1/3. Negative times negative is positive, and that's really 4 over 1. So 4 times 1 is 4, over 1 times 3 is 3. So we get 4/3, and we're still adding that 7. Then we can multiply the negative 6 times the 1/9. Well, that's negative 6 over 1. So negative 6 over 9 plus 4 over 3 plus 7. Well, we need to combine these fractions, and this is good fraction practice, guys. So we notice that we can't add them together yet because they don't have the same denominator. But 6 over 9 is divisible by 3 in the top and bottom. So we divide the 6 by 3, divide the 9 by 3. We're going to get negative, well, 6 divided by 3 is 2. 9 divided by 3 is 3. And we can just copy down the rest of it. So negative 2/3 plus 4 over 3 plus 7. When focusing right now on the fractions, we have negative 2 over 3 and positive 4 over 3. Well, if we have negative 2 and positive 4, they have the same denominator, so we can add them together now. 4 take away 2 is 2. So we have 2/3 left just from our fractions. Add that to our 7, we're going to have 7 and 2/3. So this is going to be the y portion of my vertex. So we have our x and y. Well, so we finally have the vertex. Now let's go back and answer the rest of the questions. Our axis of symmetry is always going to be x equals a number. The number that we're going to use is the x coordinate of our vertex, which was negative 1/3, negative 1/3. So negative 1/3, x equals negative 1/3. We want to know if we have a max or a min. So since we're opening down, our picture is going to look something like this, right? And that point is greater than all the other points on my curve, so we have a maximum. And the reason I know it's opening down is because I have that negative 6. What's the value we're going to use? Well, we have a maximum at the y value. So 7 and 1/3 is going to be our maximum value. Our y-intercept, well, our notes from the front page said the y-intercept will always be the point 0, c. And c is going to be that last number here. So our last number is 7, so our y-intercept is 0, 7. Well, our domain is going to be all real numbers because it always is, and we can plug any numbers into it. Here. There's no numbers that we can't. For our range, we know that we have a maximum, we're going downwards. So we know we're going to be y is less than or equal to something. What is that something? Well, it's the y value here at our vertex. So the y value here is 7 and 1/3. Great. So we have all of our information. That was really the hardest part. Now we're going to actually go back and try to graph this thing. So let's start with our vertex. Negative 1/3, 7 and 1/3. Now, because they are fractions, we just have to kind of do our best. It's not going to be perfect. Ooh, I made a little boo-boo. We had 7 and 2/3. We got to change this. 7 and 2/3, 7 and 2/3, 7 and 2/3. Yeah, hopefully you guys saw that and fixed that anyway. So 7 and 2/3 everywhere. So we're going to go over negative 1/3, so not even 1, so a little bit to the left of our origin. And then we're going to go up 7 and 2/3. Well, here's 7 and 2/3 is almost at 8. So kind of like at the bottom of the 8 there. Let me see if I can make that a little bit brighter with my red pen. Not much better. I'll do the rest in red. I think that'll show up better. So our vertex is right here. And then we know that our y-intercept is at 0, 7. Well, 0, 7 is right here. And we know that we have a axis of symmetry. I'll do that part in blue. Axis of symmetry is the line that goes up and down through our vertex. And this axis of symmetry is very, very, very close, 1/3 away from our x-axis. So we got to be very careful when we draw this. All right, so there is my axis of symmetry. And if we think about this, this y-intercept that we just put on has to be equal away. So it's just 1/3 away on the opposite side. So we have our 3 points, 1, 2, 3, very, very close together. And then we can just connect them. This isn't going to be a great parabola here just because we don't have a lot of information. But this is enough information for me when you guys are doing these ones. All right, guys, plot your y-intercept. Use your axis of symmetry to get another point. Once you have your 3 points, connect them, call it a day. All right? So that's it for this example. Thanks, guys.